Okay, so this video is going to be for lesson 7 in your workbook on trigonometry. The lesson is on page 249, so you need to be open to this page. And this is the last lesson in trigonometry. After this lesson, I'll give you the homework questions, and then I'll assign you the practice test, which is lesson 8. So what we are doing for this last lesson, we only have 3 examples to get through. The first thing that you need to be able to do is 2 triangles put together. And there's going to be a pattern that you're going to do to solve this. And the pattern is, if you are able to, the first thing you want to do is solve the common side. So write that down for this. So solve the common side. So that's sort of the approach or the strategy that you will take when you have 2 triangles put together. Okay, based on these 2 triangles, let's see if we could label everything according to what it says. So it says in the diagram, QS is 32 millimeters. So put down your 32 for QS. PQS is 50 degrees. So that's going to be angle Q. And remember, if we trace it, P to Q to S would be that angle there. But that will be 50 degrees. So we'll put that in. And then angle RPS. Okay, this one you're going to have to be careful with tracing. You can't just for this guy say it's angle P. Right? Because if you look, angle P sort of has 2 different angles within it. So angle RPS, if I was to trace that from R to P to S, they want that angle there to be 61 degrees. So let's put the 61 where they've asked for that. So this would be 61 degrees. And then it says, use this information to determine the length of QR. So QR will be this entire base of the triangle. And we already know that this is 32. So we're really just figuring out what RS is, and then we're going to add it to 32. So the strategy that you want to do is you always first see if you could figure out what's the common side that the 2 triangles share. So the common side would be this guy here. And say to yourself, do you have enough information from one of the triangles to calculate the common side? And you should have enough information. So Alexa, which triangle would I work with? The left triangle or the right triangle to calculate this red side here? The right triangle. So what I want you guys to do is I want you to put an X, what we're trying to calculate, and we're dealing with the right triangle. So give that 50 degrees a set of eyeballs, and X would be your opposite side, this would be your hypotenuse, and this would be your adjacent. So from there, we're solving for side X, so box in your 2 sides. Always box in the side you are looking for and the side you are given. Sebastian, what trig ratio do you want me to use that has O and A? Tan. So the tan of my given angle, 50 degrees, Hermes, tan of 50 degrees is equal to, Hermes, what would it be equal to? No, what do I write, Hermes? I need you to pay attention. Yes. Okay, from there, X is on the bottom, so get rid of it. X divided by 32, multiply this guy by 32, this guy by 32. Remember, we round and trig at the very end. So Kieran, what do you get when you put that into your calculator? Perfect. So let's just, this side is called PS, right? So this is PS. And he said it's 38.1, sorry, 38 point what? 136, and then I'm just going to do dot, dot, dot. And actually what I really should do is I should put this on my calculator so that I've got it stored on there. So 32 times the tan of 50. We should have typed in our sine of 90 to check that we get 1. I am in degree mode though, so I haven't changed it for my 30 level class. Yeah. And the reason why I suggest on a test doing dot, dot, dot is so that you're telling yourself, use your answer on your calculator. Yes. Would it be easier putting, which one did you say? Yep, that's what I have here. Oh, it's up to you. That is completely up to you. When you're doing intermediate steps, you could do it that way. And then at the end, I would say, okay, they want QR. I would just have to call the last one QR. What you call it intermediate is I'm good with either. Yep. Okay, so now what I'm going to do is it's a bit of a mess. So I'm just going to erase this. And I'm going to put in everything that I now know. So I know that this was 61. I know that this was 32. Um, this was 50, and this was 38 point, I'm just going to put 1 for now, 38.1. So the strategy is you always solve the given side first. You use one of the triangles, sorry, not the given side, the shared side. You use one of your triangles to solve that shared side. Then you could jump to the other triangle and solve what we actually need in this triangle. So in this triangle, what I need is this length down here. So I'm now going to move my X there. And I'm going to say, okay, according to the left-hand triangle, give the 61 degrees a set of eyeballs. This would be your opposite. This would be your hypotenuse. And the 38 would now be your adjacent, right? Because now I'm just dealing with this left-hand triangle here. Okay, because we're going to box in our two sides, I'm going to box in O, the side I'm looking for, and then the given side is what we calculated. So for these, we have to have done the first calculation correctly in order to get the final answer correct. O and A is the same ratio, so tan. So now we're doing the tan of 61 degrees is equal to opposite over adjacent. Get rid of that divide by 38.136 by multiplying both sides. And then you're going to see in measurement in trig, we, again, round at the very, very end. So now I'm going to take that answer on my calculator. So I'm just going to go up and I'm going to select it. And I'm going to times that by the tan of 61. And I get, now X is 68.799. Do I box that in, Cohen, and call it a day? Am I done? No, what do I do now? Because that's right. So I just calculated that RS is 68.799. They want that entire base. So they want this distance here. So to that number, I have to add 32. And I'm going to call that QR. That's how they asked for it to be called. So QR to the nearest millimeter. So let's take that number and now let's add 32 to it. And we get, what would you guys round this to? 101 millimeters. Okay, let's do one more practice like this, and then we'll do our third and last question. So again, two triangles put together. These two triangles here, what are you going to solve first if you can? What's your strategy? The common side. So Jack, if we're solving, what's actually the common side first? What letter to what letter? Yep, E to C. That's the common side. So I'm going to put my X there. And then Jack, which triangle, left or right, am I starting with? The right side. So according to that triangle, that's the opposite side, the hypotenuse, and the adjacent. Holly, what two sides do you want me to box in? Yep, box in what you're looking for and then what we were given. O and H, same trig ratio or different trig ratio? Which one? Sine. So the sine of my given angle is 39 degrees. Sine is O over H, which is x over 3.7. So x is on top, so we're looking good. Multiply both sides by 3.7 to isolate your x. X, which is equal to, I'm going to call it EC or CE, doesn't matter. 3.7 times the sine of 39. And I'll keep this stored in my calculator because I'll probably have to use it for something. Actually, I'm just going to clear everything. So 3.7 times the sine of 39 degrees. And we should be getting 2.328 dot, dot, dot. Okay, so from here, let's erase this. And let's just write in 2.3. And I didn't even like read the rest of the question. I don't even know what they're asking for, right? But I know it's probably, I mean, like that strategy is always a good one to solve that side. Calculate the measure of angle BEC. Trace this. And put your x degrees at BEC because it's not angle E, because angle E has two different angles. So to find it, we trace B to E to C is that guy there. So that's where my x goes. So again, what you always do is you work in one triangle to get the common side, then you jump to the other triangle to get whatever they're looking for. So now I'm working from this triangle. According to my given angle, label. So that would be opposite, hypotenuse, and adjacent. And from here, Antonio, we're solving an angle. What two sides do you want me to box in? Or like between A, O, and H. Yes, so he said A, and he said H. Yes, whenever you're solving a given or an unknown angle, you need to box in two sides that are known. So A and H, Holly, what trig ratio? Cosine of my given angle, which I don't know. Cosine is Ka, which is A over H, 2.3 over 4.6. I'm actually going to write 2.328 for now to remind me that I have to take that answer from my calculator. So we're finding an angle. This is an inverse function. You guys did really well writing this on your test. How you would write that is the inverse cos, which is written as the cos of -1, but it really is not -1, just the inverse cos. And then open bracket, 2.328 over 4.6 equals. How I would type that in, selecting what I have, is I would do the second function cos to get my inverse cos. I'm going to go up and I'm going to get that answer there. And I'm going to divide that by 4.6. There's one question on your unit exam that if you do not go up and select it, you will be off by a 0.1 and it'll be enough to lose a mark, right? So always just get into that habit. Yes. You know what? You could do either or. You could go up and select and it'll bring that entire thing down, or second answer. Same answer. Yeah, you'll get the exact same answer. Okay, and then the reason why it's good to sort of go up as well to select is because sometimes we might be going up a few times to select something, right? Depending on where we did work. So if we look at this, what do they want me to round to? This angle? Nearest degree? Okay, so 60 degrees. And then I'm going to say, okay, what did they want me to call this? So I scroll back up and they said angle BEC. So if this was a test question, I would say angle BEC is equal to 60 degrees. Students who write this, angle E is equal to 60 degrees, I would have to take off a 0.5. Do you know why that would be? If I go up, Kieran, why would I take off a 0.5 for saying angle E is 60? Yeah, angle E is really this guy here. That's truly angle E, right? So it'd have to be angle BEC. Okay, let's do the last question, which you are going to star. Two buildings, one's taller than the other. You star this guy and you put exam, and it is on your practice exam. So when I give you the homework, we'll also talk about the practice exam. This one's on here. And literally, you guys, for your final exam, like your unit exam next week, it's always going to be the same questions. Two buildings are spaced so many meters apart, and the buildings will always be different heights. You will have to draw the buildings on your test. So it's just going to be like a blank piece of paper, and you're going to draw the buildings. Okay, so let's fill in everything we know. In 2003, doesn't really matter, the tallest building in Rockyville was the Metro building. So this was the tallest building. And then later on, a developer came in, built the Gampero building, and it was taller. So who cares? We don't need to know that information. From the top of the Metro building, so from the top of the Metro, the angle of elevation to the top of the Gampero building is 24 degrees. See if you could figure out where that goes. That's the first thing. Can you figure out where the 24 degrees goes? So from the top of the Metro, you could look straight ahead, or you could look up at the top of the Gampero. Remember, it's always measured from the horizontal. So you could look straight ahead, or you could look up. That is 24 degrees. Here's what you do. As soon as you get this angle, actually, we don't have enough information yet. Let's fill in a few other things. The angle of depression from the top of the Metro to the foot of the Gampero is 56 degrees. Who knows where the 56 goes? So does it go, you guys, in number 1 or number 2? Number 1. So Jack says number 2. Does anybody disagree with Jack? The whole class. Jack, the angle of depression or elevation is always measured from what? The horizontal. So you guys, watch. He could look straight ahead, or he could look down, always. So that 56 degrees would have to go here. Always, that's going to get some of you on this test. This is going to be like a 6 or 7 mark question. And that's going to get you right from the beginning. Okay, as soon as you put this in, find your Z, your backward Z, and the angle of depression is always equal to the angle of elevation. So I'm starting it in pink, and this makes a Z. Once you get that depression in, always get the elevation in. Piper, do you see where it would go? It would go on the bottom right here. Is where you should be putting it. So if this is 56 degrees, this is my Z here, and depression is always equal to elevation. So I'm just going to erase this. So if that's 56 degrees, this guy is 56 degrees. Yes. Yes, that's right, because these two, and you will never need this triangle here, you'll see. Okay, so what I'm going to do is I'm just going to erase this now. So I'm going to put my 56 there, my 56 here, and my 24 degrees here. And then the buildings are 45 meters apart. So put your 45 meters in a couple different places. So I would put your 45 meters right here because I could now calculate the height of the Metro using that triangle there. I'm going to be able to figure out the height of the Metro. And I hope you could see this, but I also have enough information to figure out this piece of the Gampero. Because you guys, if this is 45, what's this triangle distance here? 45 as well. So as soon as I put the 45 down here, I'm going to put that 45 here as well. And now what we're going to be doing is it's going to say determine the height of each building to the nearest meter. So let's start with the metro first. So the metro would be this triangle here. And I just simply need to put my X there. And according to 56 degrees, let's label our triangle and let's calculate the height of the metro. So according to 56 degrees, that would be the opposite, hypotenuse, and adjacent. And I'm going to box in what I'm looking for, which is my X, and what I'm given. So using this triangle here, I could calculate the height of the metro. So O and A. Jimmy, what ratio do you want me to use? Tan. Jimmy, the tan of which angle? Yes, tan of 56 degrees is equal to O over A, which is X over 45, times both sides by 45. And then I'm actually going to write this X is going to be the height of the metro building. So instead of writing X, I'm going to write metro building is equal to, let's figure out what the metro is. So again, I'm going to clear my calculator. And I'm going to type in 45 times the tan of 56. So 45 times the tan of 56. Okay, now they want the metro. They want each building to the nearest meter. So how much is the metro? 67. So here's what I'm going to do. The metro is 67 meters. So I'm going to box that guy in. Then what I'm going to do is I'm going to go over to the Gampero now. And do you agree that from here to here, this would be 67 meters? Do you guys agree with that? Yeah. Now I just have to use this triangle up here to calculate this top piece of the Gampero. Then I'm going to add the two together. However, I'm not going to add 67. Cade, what would I really add on my calculator? Yes, the entire thing, right? I'm going to round at the end. So let's go to that last triangle. 24 degrees. I'm now finding this guy, which is my opposite. This is my hypotenuse, and that's my adjacent. Lucas S., what two sides do you want me to box in? The O and the A. And which trig ratio am I using? Tan. And Lucas, the tan of what degrees? Yes, tan of 24 degrees is equal to O over A, which is X over 45. Thanks, David. Times this by 45, times this by 45. X is equal to, I'm going to keep that as X, 45 times the tan of 24. 45 times the tan of 24 gives me 20.035. So this piece here, it's 20.035. But the Gampero, I'm just going to call it the G building, is that number plus whatever this number was not rounded. So I go back to my calculator. So here I would just do plus, and I get the exact same number if you selected. I'm going to scroll up to that guy. So the Gampero to the nearest meter would be, everybody's getting 87? So this by far on your unit exam would be worth the most. There's going to be one that you're going to practice for homework, and there's going to be one on your practice exam. Yes. I would not even notice. Yep, because what I would be doing is I first look at your answer, and then from your answer, if something was wrong, then I have to go back and look at your work, is how I mark it. Yep, so I wouldn't even notice that. Yep. Okay, that's it. We don't do class example 4, so you're not required to do 3D objects. So if you want to flip to your homework, we're going to set up a couple questions and then we'll talk about the practice test. Circle that as well. So if you guys could circle 1 ACD and 2A. Those are the two triangles stuck together, solve the common side. Then circle 3, 4, and 5. Sorry, and you know what? Number 5, you don't need to do. So we're going to do just up to number 4. So we'll set up number 4 together, which is the two buildings questions. Okay, so 1 ACD are your triangles, 2A. Number 3 maybe we'll set up after together, and then number 4. So again, this will not be given. You just have to draw two buildings, draw one taller than the other. But let's see if we could set this up. The angle of elevation from the top of the Pi Hotel to the top of the Sigma office is 17 degrees. So people at the roof could look straight ahead, or they could look up. The angle of elevation is always measured from the horizontal, so the angle of elevation is 17 degrees. Then what I want you to do, without even reading the question, the people up here could also look down, right? So the people at the top of this building could also look down. So I want you to draw your line going down. And see if you could figure out the depression. So those people, they could always look ahead or they could look down. So it says the angle of depression from the top of the Pi Hotel to the foot of the Sigma building is 60 degrees. Who thinks they know where to put 60 degrees? You guys, look up here. 1 or 2? 1. 60 degrees goes here. As soon as you put that one in, say to yourself, depression is equal to elevation, or elevation is equal to depression. So find your Z, your backwards Z, and do your other 60 degrees. So this would be the Z, and this guy would be 60. Because remember, at the bottom of the building, a little mouse could look straight ahead, or he could look up. So that would be the angle of elevation. Okay? Oh, look what they give us here. The height of the Pi Hotel is 150. So they gave me this. So that's new. What could we calculate now based on just this triangle here? What could I calculate? The distance between what? The two buildings, yes. So what it does is it says, A, complete the sketch to illustrate this situation. So this would be the sketch that you would have on your test. Then determine the height of the Sigma office. So they want this guy here. But what you're first figuring out is I need to know how far apart these buildings are. So I need to put my X down here. You're going to use this triangle to figure out how far apart the buildings are. So opposite, hypotenuse, and adjacent. And you're going to box in the opposite and the adjacent. Because once I figure out how far apart those two buildings are, I could then put that number up on this triangle here, right? So when you guys get how far apart the buildings are, you're going to put that number up here. And then you'll be able to calculate that X. So you guys, let's not do it now. Let's set up a few things, and then you'll start at this question if you want. Okay, let's quickly do number 3. Let's set number 3 up together. two trees in a park are 14.8 meters apart. The observer is halfway between the trees. So can you guys quickly calculate on your calculator, what's the distance from this tree to the observer and this tree to the observer if if the distance between the two trees is 14.8? What are you getting? 7.4. Yep. So this is 7.4 and this is 7.4. How tall is she? 1.8 meters. So when her height, here's what I do with her height. I'm going to put this piece of the tree is 1.8 meters. So this is her height. Even though it says like it's her eye line, but you just say that's her height. And then this piece of the tree is 1.8. Okay? So she could look straight ahead, or she could look to the top of each tree. And I know that this is 7.4, and I know that this is 7.4. The angles of elevation from the tops of the trees from her eyes are 17 degrees and 23 degrees. Which one with the 17 degrees, which one's the smaller angle? The left or the right? The left. So this would be 17 degrees, and this would therefore have to be 23 degrees. Show this information on a diagram, so we're done A. Determine the height of each tree. So you've got two different triangles. What are you going to do when you calculate the opposite side for each one of these? What are we going to add to it? 1.8. Okay? Okay, so you're going to do those 4 questions. Now I'm going to give you the practice test. So can you guys flip to here? And you could just write at the top of your practice test numbers 1, number 2, and then write 4 to 12. Okay, and these are really good test questions. So this is going to combine now all of the lessons. Yes. Let me have a quick look. Okay, so for the numerical responses, not number 1. Actually, I don't think any of them, because they're all on area questions and we haven't done measurement yet. Yes, so yeah, I'm okay for the numerical response. Yeah, because their measurement or their surface area volume, we haven't done that. Okay, so that's going to be for the practice test. And then you guys, the last thing that you have that I just want you to look up here, and then I will save the video, is you have this practice exam, which I'm going to upload the blank copy. And here are the complete work solutions for it. So all of these questions are fair game for your trig test. This is a really good practice. Like when I make your trig test, I take a lot of things from here. And I believe in here, so like here's your 2 triangles stuck together, solving the common side. There's an isosceles question, so that's good for your test. And then here's your 2 buildings. Okay, so you'll get all of this done today. And that's it for the last lesson.